Welcome to Spring LIB.
Okay, we're working with 1,4-dichlorocyclohexane, and we're told it's the trans isomer, which means the chlorines will be on opposite sides of the rings, one above and one below. Great. Now we need to convert this to a chair drawing. I do this by drawing a series of parallel lines, 2 at a time. And then let's just say this is carbon 1, 2, 3, and 4. And we'll say this is carbon 1, 2, 3, and 4. So on carbon 1, there should be a substituent axial up and one equatorial down. And in carbon 4, we should have a substituent axial down and equatorial up. Now we know that the chlorine can be really either the upper substituent or the lower substituent, but let's just draw it as the upper substituent, so it seems to be consistent here, but technically it doesn't really matter. What does matter is once we've chosen this configuration where the chlorine is axial up, that means the other chlorine has to be the lower of the two on the other side of the ring, so it's going to be axial down on carbon 4, and hydrogen will be here. Now we need to draw the chair flip version of this, and I like to do that by drawing 2 parallel lines in the opposite direction, connecting them by drawing another couple parallel lines. I call this carbon 1, 2, 3, and 4. So I always call the rightmost carbon 1. Okay, so now we know carbon 1 should have a substituent axial down and equatorial up. And carbon 4 should have axial up and equatorial down. Now, if we've done a ring flip, chlorine should no longer be axial, it should be equatorial. So we know that chlorine must go there and the hydrogen must go there. And previously on carbon 4, we had an axial chlorine. So after the ring flip, it must be equatorial. And our proton must be axial. So we've got to decide between a structure in which both chlorines are axial, which we know to be less stable. Axial is always less stable than equatorial when we have functional groups, or the version where both chlorines are equatorial, meaning they're not, right? Remember, the axial things have steric interactions with the other 3 axial substituents on the same side of the ring. So the version in which none of the chlorines is axial and doesn't have any of these 1,3 diaxial interactions is going to be more stable. So this is the better of the 2 structures, both chlorines equatorial.